As we have completed with this section 8 where we have seen this advanced part on this G plus 4 story building, that was the model 6, and over which we have seen some advanced part, that is the introduction to lateral loads, and then after we have seen for the theory of earthquake, then define the earthquake loads. We have seen how to define it as per the Indian standards, that is the IS 1893 2016, that is the code book. And then after we have seen how to assign this earthquake with respect to this diaphragm by defining the diaphragm and assigning the diaphragm. Then after we have seen for this, define the wind loads, how to define them with respect to the IS 875 part 3 2015. And then after we have seen what are the this load combination came when we have added this earthquake and the wind load. With the combination of them, what comes the load combination, we have seen them. And then after we have seen for this define mass source. All this concept was basically not part of this course, but to show you the advanced techniques, advanced part of this ETABS, means the earthquake analysis. So I have just mentioned this part also and added it in the form of the advanced part. And that's how we have completed with our course, over which we are now going to see for the course conclusion and the earthquake perspective. And as we have completed with this all the six models, and our complete ETABS course from 0 to hero for the beginner to intermediate level has been completed with the complete modeling, analysis and design in ETABS. Okay, so basically we are currently going through our final lecture, that is the course conclusion and the earthquake perspective, means what are the we going to see in the future advanced part of this ETABS in the form of the earthquake. So before we officially conclude this course, I want to clarify one important thing, that is earthquake engineering is a very large subject by itself. Okay, and it's can't be taught by just showing you how to show in the ETABS to work on it. We have to go read the books, see the detail of it, and basically this earthquake part is a whole concept, and over which we are the advanced part is been present. Okay, earthquake engineering is a very large subject by itself. In civil engineering, earthquake analysis and the design is taught as a completely separate full course, not just one chapter. In this ETABS course, my goal was not to make you an earthquake design expert. I was just making you as a I have just covered your full foundation. Okay, my goal was to give you the correct structural foundation so that when you see the earthquake analysis in ETABS, you understand what is happening, why it is happening, and what the code expect from you. Okay, that was this course conclusion. Now we will see for the earthquake, means what is earthquake analysis and what are the future steps for this you to go beyond for the earthquake perspective, and see the detail of it, earthquake as a form of the structural engineering and analysis. Okay, so what is earthquake analysis? Earthquake analysis is the process of understanding how a building behaves when the ground shakes. Basically, when an earthquake happens, the ground moves, the building's base moves with the ground, right? The upper floor resist the movement due to inertia. The internal forces develop in the beam and the column and the slab. And the key idea, that is the earthquake does not push the building. The earthquake does not push the building. The building resists the motion because of its own mass. That resistance creates the lateral force. So now let's see why earthquake analysis matter. In the normal design and in the when we are going for the earthquake, what is the difference we will see. In the normal design, we design for the gravity load that acts downward, and basically the gravity loads act downward. And this in the normal design, column mainly carry the compression and the beam transfer the vertical loads. Okay, but during an earthquake, forces act horizontally, column bends, beams bend sideways, the entire structure sways, means it will move aside. Okay, means it will swing. If not controlled properly, this can lead to a soft story mechanism, column failure, structural instability. Earthquake design is not about just stopping the movement, it is about controlling the movement safely. I am not going in depth here. I am just explaining the basic of this earthquake. So in the future, for if you want to pursue the earthquake part for the high-rise building, you should be doing for this earthquake part only. Only this gravity. As we have seen for this basic to intermediate level, we have covered what we have covered the basic part. Means basic part means what? We have seen how for the gravity load and for the this 4 to 5 story building or 3 to 4 story building, what's the criteria, and for this purpose we have seen completely how it actually works. Okay, our course was based on this 2 3 4 5 story building, and till the intermediate level you are being perfect in it. And for this 2 3 4 story building, earthquake part is not that much required. We generally do it for the earth, for the gravity loads only. Okay, then after we will see how building reacts during the earthquake. Every building behaves like a vibrating system. There are basically three important behavior of this earthquake. That is, the first is the sway, then the second is the time period, and the third is the mode shape. In the sway, the building moves side to side. In the time period, short building move faster but less. Then the tall buildings move slower but more. Means it says that time period for the action of this earthquake, how the building will move in the based on this time period. Short building move faster but less. Tall building move slower but more. Okay. Then the mode shapes. Low rise building vibrate mostly in one shape. High rise building vibrate in the multiple shape. This is why the tall buildings requires the advanced analysis. Now let's see the types of the earthquake analysis. There are basically three approaches we do for the earthquake analysis. That are the three methods. That is the equivalent static analysis, response spectrum analysis, and the time history analysis. Now let's see each of it, what is it. Then the equivalent, first one is the equivalent static analysis. It is basically used for the low rise buildings or the regular structure. It treats the earthquake forces as a simple horizontal load, simple, basic, and suitable at the basic level. Means for the low rise building and a regular structure, that is the 3 4 story building, it is very much okay. We generally do it for the equivalent static analysis. If the building is in different zone or the earthquake prone area, and if it is a very means medium size or greater building like the high rise building, then we go for this response spectrum analysis. Response spectrum analysis used for the medium to tall buildings, structures where the vibration behavior matters, considers the multiple vibration modes, and it is more realistic than this equivalent static analysis. Then the time history analysis, which is basically used for the very tall or the important building complex or the irregular structure. Means what are the steps? First of all, if the building is smaller in size, we go for this equivalent static analysis. When the building is in the medium to tall building, we go for this response spectrum analysis. And for the high rise buildings, that 30 40 50 story building or 20 above 20, we go for this time history analysis. And for the medium to tall, we go for this response spectrum analysis. Okay, this time history analysis used for the very tall or the important buildings. Complex, they are basically the complex or the irregular structure, uses the actual earthquake records. Most advanced, this is the most advanced method of all things of these things. Okay, and it uses the actual earthquake records. Means whatever the earthquake has been happened in the past, it calculates that in the form of this and in the form of the record, and it will suggest and it will form the record and analyze the building based on the site and all these things. Okay, and it is a very advanced analysis method. Then after, what we learned in this course, what we are learning here is the basic and the essential part of this earthquake analysis required to use the ETABS correctly for the real project. Means whatever I am currently telling you about the earthquake, it is the basic part that I am just telling to be noted you for the advanced concept of this earthquake analysis. Okay, this includes the understanding the earthquake load as per the IS provisions, knowing when the static analysis is sufficient, knowing when the dynamic analysis is sufficient. Means whatever we have seen, that is the static analysis, it is used for the low rise building. Response spectrum and time history are basically for the medium and the tall buildings and the important buildings. This is exactly what a junior structural engineer or an intern is expected to know. Means whatever I have told you, I have taken in this course, is basically required for a junior engineer or for a intern. Okay, and everything rest of it is been for that we have to read the books, and we will be getting that knowledge when we go and do the work at the company. And for this interns and this much knowledge I have taken is sufficient for the to be an intern. Okay, as it covers all the parts of the gravity, and then after it covers for the earthquake part. Okay, then after means the basic of earthquake, and we have covered the basic all concept for the gravity loads. Okay, we have seen for the how to model, analyze and design our building. Then after the important boundaries, the advanced topics like the detailed earthquake theory, structural dynamic derivations, non-linear time history analysis, performance-based design, then the full ductile detailing philosophy are outside the scope of this basic to intermediate course that I have cleared you perfectly, right? And these concepts are all the advanced part. And when you will going for this uh, high-rise building, then you just need this important boundaries that are the advanced topic you should know, and they are very much important. Okay, those topics belong to a dedicated earthquake engineering program. Means it is a complete 30 to 40 hours of the course being present for this earthquake. Okay, what changes in the high-rise building? What will change in the high-rise building? High-rise building introduces the higher mode effect, significant dynamic behavior, torsion, P delta effect. Some of these are the this part of this high-rise building is the earthquake parts which are being present here. Then the drift sensitivity, structural irregularity. In the tall building, earthquake response becomes the dynamic, not static. Means it says that we generally do for the response spectrum analysis, that is basically the dynamic analysis, response dynamic analysis, not the static. Static is basically for the low-rise buildings. Okay, then this is why the advanced methods are required. If you want to design the high-rise building, what you should be learning, your next learning step should be structural dynamic first step. Then we have to go for this response spectrum method, time history analysis, ductile detailing principles, what are they, we have to see all this concept very clearly, and then after only we have to go further. Then we have to see for the advanced structural systems like the shear wall, cores, and outrages, and tube system. All this concept is for the high rise building, and it is for the advanced part. Without structural dynamics, means what are the basic and what's the theoretical knowledge you require, earthquake design becomes guesswork. Means we cannot directly show you by showing you the software use, and you will be understand it. You have to be going deep into it. Okay, then the final message of this course: at the beginner level, what we have seen, you have learned how the building stands, and at the advanced level, what we do that you learn how the building survive the extreme extent and events. And we have seen for this beginner level all the gravity part and the basic of this earthquake analysis. Okay, in the advanced part, whatever concept I have taken means explained, that part comes under this advanced part, and then only you will become the design earthquake design expert. Okay, this section is the bridge between the basic structural engineering and the advanced earthquake design. It prepares you for the next level without hesitating and without overwhelming you. Okay, so that's the bridge between both of it, and that was the final message. Then the course conclusion: after completing this course, you are not just an ETABS user. You understand the structural behavior, how it works, how to model, how to analyze, and how to design. You have designed perfectly 6 models, and see the result. How when the design results were failing, what we have done completely, it changed the result, and how the section dimensions we changed when the this design part has been not proper. Means at the part of designing, what we do that many times our building fails, right, as the members of it like the beam and the columns fails when we do the designing part at start. Then after, what we do the once again the change the dimensions and section and the grade of concrete, and all these things we have seen completely in our 6 models, right? Now you can interpret the analysis result logically. You can and based on your knowledge, you can assist in the real consultancy project confidently. Okay, you now have a strong foundation. Okay, you started this course by learning the software. You are finishing this like thinking like an engineer, and that transformation is what it truly matters. This is just the beginning of your journey in the structural engineering. Keep building not just the structure but your expertise. And that's it for this course. Okay, and we have completed our ETABS course. So that's it. And once again, congratulations on completing your course. That's it.